Okay, this is in the page. So now we are in the message handler. We got a communication reference. No. Okay, the device has responded with 80 bytes. That's okay. Yeah. See if this loops works here. Actually, they are all 0, I think. So in this device, it's just initialized with 0. So that's probably now just for zeros. So here we have 20 zeros from the device. It's okay. And then we are back in the page. And it displays the zeros. And now, of course, I could, instead of the table, I could, for example, use a graph or third-party control. Then that's then up to the UI. And yeah, obviously I would refactor this code, so maybe not do this communication stuff directly in the message handler. But that's just here for a demonstration. Okay, so this was now something from the UI to the device and bypassing all the built-in parameter functionality. Are there any questions for this?
In your frame application, the implementation of the communication interface, you use the direct method call at the moment. So, but it doesn't matter how the DTM wants to correspond to the device. This has the frame application has to decide how the communication interface is implemented. For example, in remoting or direct message calls or.
So it's basically like this. We have. Can you see this, or should we turn off on the lights? So we have the device DTM. And we have the communication DTM. And the ComDTM has the channel object. So this has basically the interface for the communication, the transactions and this stuff. And now the frame is in the middle. So the frame basically creates something like a proxy object for this channel with the same interface. And the device DTM gets a reference to this proxy channel. And so we are basically here, we are talking to this proxy channel. And now it's up to the frame application how to forward the things from here to here. And in our frame application, the simplest constellation is that everything is in one process. So then this will be just a direct method call, one-to-one. But if, for example, let's say this DTM is a CLR2 DTM, and it says I cannot run in a CLR4 environment. But this one is a CLR4 DTM. And maybe the frame is also CLR4. Then it has to put this one into a different process, because it cannot start it in the same process like the frame. And then it has to find some way to cross the process boundary here. And here our implementation uses a named pipe. But there could be maybe another frame which maybe is a distributed system. So let's say here the communication DTM is on some communication server, and the device DTM is on your desktop. Could be like this. And then maybe the frame has to use remoting or whatever, WCF. But that's basically transparent for the device DTM. The only thing which is different to FDT1, so in FDT1 it was possible for the COM DTM to implement a private interface here. And then if the device DTM and the COM DTM are from the same developer, they could cast this and call some special things. So this is not possible anymore because the private interface is not here. So this would only work between the frame and this channel. So this is maybe the disadvantage.
In FDT2.0 there exists a special interface, a generic interface where you can send messages to emulate such private interface.
That's right, yeah. So, So this one has another interface for the, I think, IDTM messaging. Which is very similar to this UI messaging, but just between two DTMs. So, and the DTM can get a proxy for this one. And then they can exchange messages through this interface. But those have to be then those serializable messages, the same like we used here in the UI. So it's not so convenient anymore, like maybe, but still possible. Okay?
Yep.
Yeah, so maybe in the last couple of minutes we can just have a short look at one area which I think was not covered now. So we didn't look much at the communication DTM. So in this case here, this is relatively simple. So basically I have a communication driver which so this just uses a WCF connection to this device. So it needs the server part of the device address, creates a channel to some interface here, and then it can forward transactions. So of course let's say in a real communication protocol, this driver is probably much more complex, maybe a hard driver or whatever. but the principle would be the same. So then in the ComDTM we have to implement the child communication class, and this basically has the three methods: connect, disconnect, and transaction. So, and in the implementation of this here just uses I think, where can we see it? Here, so this is basically an instance of this driver with the WCF connection, and then it forwards everything to this driver. So it gets the FDT2 transaction requests, talks to the driver. In this case, this is a synchronous operation. And then builds the FDT2 responses and returns them. And also the communication DTM can then implement the scanning functionality. It has to do some sort of management of the children. So there's a class where it has to respond to validate add child methods. So here I could refuse to add a certain child for some reason. One part which is a little bit complicated here is address handling. So there's a method set children addresses. This will be called by the frame when a new child was added, and there are three modes for this. So either the frame requests to open a user interface and get the address from the end user. So this is implemented here in this example where it opens this modal dialog. Another possibility is the no user interface. Here the frame provides an address which we have to set to the child. This would typically be invoked after a scan, because then the frame knows the address from the scan. So it will not request to open UI, but directly set some address. And then there's also this mode set next valid address. So I'm not so sure when the frame would use this. So our frame would never invoke this actually with next valid address. So when I add a child manually, it uses open user interface, and from the scanning, this one. But this address handling in detail is a bit complicated. So we have to get the DTM, get the network data, and then set the address. And the data structure of those addresses are relatively complex in FDT2.